the degree of one term. So now if I have a whole polynomial, like 3x squared plus 2x plus 5, the degree of the polynomial is the highest degree term. So it's the highest exponent. So whichever term has the highest exponent is the degree. So for this one, the degree would be 2. Because that's the highest exponent. And 3x squared plus 2x plus 5 is what kind of function, you guys? It's a trinomial. But what kind of function? Is it linear, quadratic, cubic, quartic? Yes, it's quadratic. Anytime you have a degree of 2, it's a quadratic equation and it graphs a parabola. Okay? This next one, the highest exponent is 3. So anybody know what kind of function it is if you have cube? It is a cubic function. Okay? Anything to the third power, if that's the highest degree, is called a cubic function. And then we have xy plus 5. So xy plus 5 really just has a 1 and a 1 on that term. You do add those together, so this highest exponent is 2. And the last one, we've got a 1 on each. So this highest exponent is a 1. And this last one is linear, as it's y equals mx plus b. Yeah. And why add? Because they're not side by side. So it has to be one term, like one single term. Okay. All right. And now it's the important stuff. Solutions to systems of equations. So systems of equations means more than one equation. It's when we have 2 equations. And there's a bunch of ways that you guys have learned how to solve systems. What are some of the ways we solve systems in this class? Brennan? Elimination. Scott? Substitution. One more way. You guys have done. Yeah, graphing. Using your calculator and finding the point where they intersect, right? So when we graph lines, we're solving systems. So there's 3 possible things that can happen when you graph 2 lines. Anybody know what all can happen? Yep.
Can they be parallel?
Yes. Excellent. So draw this out. We can have 2 lines that are parallel. Okay, if 2 lines are parallel, are they ever going to cross each other? No. So do they have a solution? No. So if you have 2 lines that never cross, they have to be parallel, and it's no solution. Okay. What else can happen when we graph 2 lines? Yeah, that's what we mostly have seen, right? We graph a line, and then we graph another line, and then we find where they cross, okay? This one has 1 solution, and we label it with an XY coordinate. Okay, anybody know a third thing that can happen when we graph 2 lines? Did you say parabola? Nope. Lines cannot turn into parabolas. Different functions. Scott?
So like where you have like
2 intersecting points? They can't cross exactly twice. Daniel? Yes! Okay, we can actually graph 1 line, and then I'll maybe do it in another color. We can graph another line, well, can't say that, but whatever. So right on top of each other, we can actually have the exact same line, right? We graph a line, I graph another line, and it's basically the exact same line. And how many times do those 2 lines touch each other? Yeah, a million times, right? Infinite. So we say infinite solutions. Infinite solutions. Okay, there's a couple other vocab words that we have to learn now, so that we have to always say. So you're always going to say, I either have infinite solutions or I have no solutions. or I have a solution and then you give the xy coordinate, which is what we're used to doing, right? So if there is a solution, the two that actually have at least one solution are these two, where they cross here or they cross here. That is called consistent. So if it has at least one solution, then we say consistent. So you got to memorize that, basically. The vocab word you have to memorize. Make sure you're writing this down, Kevin. Okay? And then no solution is inconsistent. So it's either consistent or inconsistent. And then if you have the two that are consistent, we have to say dependent or independent. So the way that I remember this is these lines right here are dependent on each other because they're the same line. Okay? So I have dependent. And for two separate lines up here, we have independent. We have to memorize those vocab words. So consistent means there is at least a solution or more. And then between the two consistent, we have to label them either dependent or independent. And if you want to remember one line on top of the big line, you can. Okay? All right. So let's see what happens when we actually solve one of these, what that looks like. Because we haven't done the weird ones. We've done the ones where we get an xy coordinate. Okay? So let's try the ones that don't give us an xy coordinate. So what does infinite solutions and no solution looks like when using substitution and elimination? So we just talked about the graph, right? So if you were to graph it, you can easily see on your calculator if you have parallel lines or the exact same line. So write that down, 2x plus 4y equals 12, and x plus 2y equals 6. So these are pretty simple problems. We'll do a quick elimination on these and see what happens. So I want to cancel either one, and I'm going to multiply through by -2 on that second equation, right? So I multiply through by -2, and we get -2x, and this times this is -4y, and this times this is -12. And I'm just going to rewrite the top equation, 2x plus 4y equals 12. What happens when we add the x's? What happens when we add the y's? What happens when we add these? So we get 0 equals 0. Okay, is that true? Yes. So if you get a true statement, these are actually the exact same line, right? If I were to divide this all by 2, don't I get the exact same thing here? So if it's the exact same line, that would be infinite solutions, which you have to say. Okay, so if you get 0 equals 0, true story, that means anything works, infinite solutions. And then we have to say consistent or inconsistent. Consistent, because it has a solution. And dependent or independent. Dependent. Okay. All right, on the next one, same thing, we multiply through by -2. This gives me -2x, -4y, -12. And I'm going to rewrite that top equation, put it here. Okay, add down, what happens to my x's? Cancel, what happens to my y's? Cancel. What do I get on the right-hand side? -1. And so I say to myself, 0 equal -1? No, it doesn't. Okay? So if you get two things that are not equal and all your variables canceled, right? There's no more x's, there's no more y's. Normally we have an x or y, right? So if all of it cancels, it's not true, then it's no solution. So what does the graph of a no solution look like? Parallel lines. Good. So no solution, and we can say inconsistent. And if it's inconsistent, you don't have to say dependent or independent. Just say inconsistent. And you're done.